Good morning, students. So today's session with continuation from the last class in module 2, the important concepts are going to discuss. That is what we call as image sampling and quantizations. So what do you mean by sampling and quantizations? Now, digitizing the coordinates is called as sampling, and digitizing the amplitude is called as quantizations. So before sampling and quantizations, our image formations. So in the screen, we have one lens, object, and image plane. How image formations. See here, when we are going to consider incident light, that is what we call as a light source. The projection through the lens, the object projection through the lens. So getting like this through the single lens. So here object, here see image of an object. This is what input object projected through the lens. In the previous one, see here. Now I'll go to the next. Projection into the discrete sensor array. It become digital image, are also called as digital camera. See here. Now in this image, you look into that sampled image. Digitize the coordinates is called sampled image. The remaining diagram, image formation, everything is as usual only. Sampled image, it will be displayed in the plane. Now continuous color discrete locations through the plane. So discrete real values image, it will be displayed in the plane. So this is what the general introduction about the sampling and quantizations. Now I'll come to the basic definition of what is sampling and what is quantizations. So if you want to create a digital image, we need to convert the continuous sensors data into the digital form. Mainly we have two types of process to digitize the analog image into the digital form. One, it is called as a sampling. Second one, it is called as a quantizations. Usually the image representations, the input image may be considered f of x comma y. That image is converted into the digital form, or the image may be continuous with respect to the x and y coordinates, and also and the amplitude. So with respect to the examination point of view, we'll write the definition of sampling and quantizations. Digitizing the coordinate values that is nothing but X and Y, is called sampling. Digitizing the amplitude values is called quantizations. Now I will consider image. The image may be continuous image. The first one, it is a continuous image. See here, this is what continuous image. And B here, it's called as a discrete scan line from A to B. So here, scan line A to B. Then sampling and quantizations. See here, you look into that sampling and quantizations. Then finally, digitized scan line. So this is one example how continuous image. The continuous image is nothing but analog image converted into the digital form. So here, so the set of these discrete locations gives the sampled functions. However, the value of the sample still span vertically a continuous range of gray levels values. So in order to form a digital function, the gray level values is also must be converted into the discrete quantities. Gray level values also must be converted into the discrete quantities. In the previous slide, what we mentioned, the grayscale divided into 8 discrete levels, the ranging from black to white. If you consider the gray levels, the ranging from 0 to 255. So number of different gray levels to be considered. And these things, it will be depending on the vertical proximity of the sample or to a vertical mask. So here, digital image formation and quantizations, continuous color input with respect to the discrete color output. We'll look into these slide. We have an image. One is continuous color input and discrete color output. These continuous color mapped to a finite discrete set of colors. So here, one real examples. This is what the real image. See, look into that pixel, grid pixels to be considered, sampled, then quantized image, sampled and quantized. Okay, so next class.